Hello, everybody out there in Math 150. We're going to be looking at Learning Objective 3 right now for Section 3.1. We are looking at identifying real zeros of a polynomial and their multiplicity. Now, the first thing you need to understand is don't get intimidated by real zeros. Zeros, again, are the solutions to the equation when we set the function equal to 0, okay? So we're talking about taking our function and setting it equal to 0. So it's the same thing we've always been working with. So to say it's a real zero, it just means that we're going to get a real number answer. Now, the second piece of this puzzle is understanding this word multiplicity, and we're going to get to that in just a second. But first, you need to know some facts about the real zeros, okay? So if you have a function where you plug r in and you get out 0, all that means is whatever you plugged in is the 0 of that function, okay? Is the 0 of f. Next, if it's a 0, you've heard me say it, zeros and x-intercepts are the exact same thing. So whatever you get for a 0 is the same as saying you get that for an x-intercept. The next one's kind of an interesting one. If it is a 0 of a polynomial, now you know a factor. You automatically know x minus r is a factor. And lastly, it means if you've got a 0, when you plug r in, you're going to get 0 out. That's all this means. So these are the facts about real zeros. So let's just look at how we can kind of think about this in an example so you can see some real math going on here. In this example, I've got f of x equals x cubed minus 25x. I could go and I could solve this, okay? I could go and I could solve this, and what I would find out is that x is going to be equal to 5, -5, or 0, okay? You could factor, you could solve that. But I'm just going to take advantage of this, and I'm going to pretend we're going to play guess and check. What if I just happen to guess? Well, it looks like 5 would work. What would happen if 5 worked? So you went and you plugged in 5, and you did this, and you said, okay, let's plug in 5 here, let's plug in 5 here. What I get is 125 minus 125. So there we go, we got our 0. So we're saying if f of 5 equals 0, what can we now say about this function? Well, we know that 5 is a 0. In part 2, we can say 5 is an x-intercept. So we know this graph's going to cross the x-axis there. Now, this is kind of the important one. It now says when I factor this, x minus 5 has to be a factor. And that's where I'm getting the 0 from. Okay, if I plug 5 into it, I get 0. If it's a factor, it means we're going to be multiplying the rest of the expression by 0. So that's where we know the 0 comes from. And then, of course, it says that r is a solution to this equation. If I factor this all out, I will get x equals 5 as a solution. Let me give you just one more example of this. Let's look at g of x equals x cubed minus 10x squared plus 8x plus 1. Now, if you went and you tried to solve where this was equal to 0, you would try to factor it. Problem is, it's not easy to factor. It's very difficult to factor this expression. But if you just took a second and played a little bit of guess and check, which isn't everybody's favorite thing to do because it takes a while, but I'm just going to guess. I'm going to guess 1. I always like to guess 1 to see what happens. If we guess 1, this is going to be 1 minus 10 plus 8 plus 1. That's going to add up to 0. Now I know all of these properties are in effect. 1 is a 0 for this problem. Okay, so 1 is a 0. 1 is an x-intercept. But here's the important one. Now I know x minus 1 is a factor, which means if I try to factor this thing, I now know it's equal to x minus 1 times a remaining factor. But that gives me a really big clue about how I could try to continue to factor this thing. Not appropriate for the section we're talking about today, but I could actually divide both sides by x minus 1, and then I can use some kind of polynomial division or long division to actually find the missing factor. So let's go and just take a look at multiplicity now. Multiplicity is the number of repeated factors a 0 has, okay? That's what it is. So in this first example, I see I've got a 0 of 1/2. So I know x equals 1/2 is a 0 in number 1. What is its multiplicity? Its multiplicity is 1 because there is only one factor of it. But in this one, I also see that x equals -6 is a 0 from this term. The multiplicity here is equal to 3. And then this last factor, I see x equals 10 is a 0, and it has a multiplicity of 2. So you're just counting the number of factors you have with that 0. In example 2, I've got solutions of x equals 4, x equals -3, x equals -4. This one's going to give me a solution of 4 again, this one a solution of 4 again, this one a solution of 3. So when I find out how many of these factors give me the solution 4, it's this factor, and this factor. So I know the multiplicity of this factor is 3. When I go back and I do the same thing for the x plus 3 factor, it has 2 factors. So I know the multiplicity of -3 in this case is 2. And there is only one factor of x plus 4. That means x minus 4 has a multiplicity of 1. Okay, how many factors do you have? So in example 3, we see here that we've got x minus 1, so that's going to give us x equals 1. That's going to have a multiplicity of 2. And then the next one, we've got x plus 3. That's going to be x equals -3. So we now know we have a multiplicity of 3 in this one. Okay, really short section this time. All we're talking about are the properties of zeros and how to find the multiplicity. We're going to learn that multiplicity has some really good properties. When we're graphing, if a 0 has an even multiplicity, what we're going to see is it touches the x-axis. So this was the last one we just did. We said that 1 had an even multiplicity of 2. Notice it touches the x-axis and bounce back up, okay? That's what's going to happen if you have an even multiplicity every time. It's going to touch the axis and bounce. But if you have an odd multiplicity, like our -3 value here, it actually is going to go through the x-axis and cross right through it. So that's the importance of multiplicity. When it comes time to graph it, we're going to know if it touches the axis and bounces, or if it actually goes through the axis. I hope this section makes sense to you. We'll be coming back with one more section for this unit. Talk to you soon. Take care, everybody.